everyone, Brianna Dignard here, and welcome back to my channel. We are continuing on with our film photography series, and in my last video, which you should go watch if you haven't already, we talked about the history of color photography, more specifically looking at the additive color processes, which were when people were trying to make color photographs using the combination of red, green, and blue light. Today, we're going to cover the rest of the history of color photography processes, this time focusing on subtractive color processes, which I will explain to you throughout this video. So let's get started. So as cool as additive color processes like the Kodachrome or Dufay color were, and as cool pictures as they produced, there are still a lot of drawbacks to additive color processes, such as the fact that you had to use a bunch of color filters when taking the pictures and then put those pictures back through color filters to view them, which resulted in a lot longer exposure times because less light was getting through. It was very wasteful of light. And in order to view your positive image, you actually had to run light through your negative or positive image just like a projector. This didn't allow a negative or a positive image to be put on a piece of paper and used in printing to make different copies. Now comes in the subtractive color process, which instead of working by adding together red, green, and blue light, worked by using the complementary colors to those things. So instead of using red, green, and blue, I produced images of cyan, magenta, and yellow and combine them together to create the color image, because cyan absorbs red light and reflects back blue and green, magenta absorbs green light and reflects back blue and red, and then yellow is going to absorb your blue light and reflect back your red and green. So by using subtractive color processes, you needed to use a lot less light, and you could also create some really interesting images. So let's dive into all of those different processes throughout history. So just like in the additive color processes, for subtractive color processes, you still needed to have 3 of the same image taken through color filters. But instead of putting them back through color filters to view them, now you're going to dye those negative images yellow, cyan, and magenta. So you needed cameras that could take 3 color separation negatives, and then you also needed developing processes that could take those negatives and turn them into the color you needed. One of the earlier developing processes that were able to do this was carbon printing. So to do carbon printing, you coated a sheet of paper with gelatin, potassium dichromate, and the correct dyes you needed to create the cyan, magenta, and yellow. When the potassium dichromate was exposed to light, it would actually harden the gelatin, and you could rinse off any of those softer areas of gelatin and form your image, and then you could use the dyes to dye it the correct color. So now you had 3 images, 1 cyan, 1 magenta, and 1 yellow. If you stacked them on top of each other and superimposed them, you had your color image. A variation on this that became very commercially successful for professional photography was called the Vivex process, where instead of using like a paper or I think they used celluloid backing for that carbon printing, they actually used cellophane, which could be squeezed and squished a tiny bit in a way to help the images be superimposed better. So in the case you didn't get 3 negatives that were exactly the right picture, you could kind of fudge it a little bit with that cellophane background and create 3 layered photographs to create your colored image. Now again, just like in the color additive processes, somebody finally went, hey, we don't need to take 3 separate images and then dye them all separately. What if we stuck them together? And this became known as the tri-pack. And actually one of the first viable, successful tri-packs was invented by Frederick Ives, same guy who invented the chromogram, and I, again, talked about my color additive process video. And in this, he took 2 glass plates with a piece of film in the middle, so a little film sandwich, and the top glass plate was sensitive to blue color light, the film was sensitive to green color light, and the bottom glass plate was sensitive to red light. So you could take an image and then you could actually separate out your 3 plates, your glass, and your film, and develop those all separately, convert them to the respective magenta, cyan, and yellow, and then combine them and superimpose them to make your image. So cool, we've put it all into one layer or pack now, but we still have to take them out and separate them to develop them. Also, this kind of led into some issues of trying to get light through all of those layers of plates, because then people started putting just different light sensitive emulsions on different layers of film and stacking them together, but it would result in blurry negatives because the light would pass well enough through the first layer, but then it would become scattered and diffused, and by the time it got to the third layer of film to get through, it was pretty much toast and didn't result in any real focused negatives. So we're gonna need some more scientific help on this to get past this blurry negative problem that was occurring in a lot of tri-packs. To get past this problem of blurry negatives caused by the light scattering and becoming diffuse while trying to get through each layer of that plate, people finally decided, hey, let's just put 3 different layers of different light sensitive emulsion onto one thing of film. So you have one piece of film, 3 different layers stacked on top of it. But it still ran into the problem of, all right, how do we get these to be the right colors that we need them to be, the magenta, cyan, and yellow that we need to make our color negative image? To solve this, people started using these chemicals called color couplers, and color couplers would undergo a chemical reaction and they would actually convert from being colorless or a different color into the proper colors you needed them to be. And as this became known as the integral tri-pack. And a scientist named Rudolf Fischer initially attempted to put the dye couplers inside each layer. So like the red sensitive photographic emulsion layer on the film would have a cyan dye coupler on it. So when it took the picture or it was developed, it would turn into cyan dye. However, this resulted in a lot of dye bleed between the layers and not great clear images, but he was definitely onto something, which brings us to Kodachrome. So Kodachrome is pretty famous and has a pretty good, I think, cult following. The Kodak even made like a movie about it in 2017 about somebody trying to go out and like shoot the last roll of Kodachrome. But Kodachrome was invented by Leopold Mann and Leopold Godowski, who were professional musicians actually, and they started working in conjunction with Kodak Labs. So they thought, there's been issues with dye bleed between the layers when putting dye couplers in the actual film layers. What if we didn't put any dye couplers in the film layers, but instead had the dye couplers in the developing process? So you would take the image normally, and then in the developing process, that's when you would start to add the color to it. And thus was born Kodachrome. And Kodachrome was basically a black and white film when you shot it, but then through a minimum of 28-step development process where it got developed, bleached, re-exposed, selectively bleached, selectively dyed, all sorts of steps. It created a color image because you eventually got those 3 images that were cyan, magenta, and yellow that you could lay on top of each other and create color. Again, this was a at least minimum 28-step process, incredibly complicated, not possible to do at home, and required you to send your images into a lab in order to have them processed. But it was a great success, and I believe it was retired I think Kodachrome was discontinued in like maybe 2009, much to sadness, because it created really pretty pictures, even if it did have a very complicated development process. So now we move on to kind of the precursor to more modern day films, and this came in the form of Agfacolor New, which was a film developed by the photographic company Agfa, and they kind of went back to Fischer's idea of putting those dye couplers in the film, but now science had advanced to the point where there was no longer as much bleed through. They had managed to anchor those dye couplers to the correct layer. So then all you had to do was develop them, create your 3 images of cyan, magenta, and yellow, and put them on top of each other. And then like Kodachrome, this Agfacolor New film was able to be processed at home by film enthusiasts. And they shared this technology with other film companies, and other film companies started making film that used the same technology of putting those dye couplers, remember chemicals that would convert the image on each layer to the cyan, magenta, and yellow inside of the film. So you could take a picture, process it, and using negative subtractive color process, you had your color image. And this is kind of the precursor to most color films nowadays, which is called a C41 process, which was introduced by Kodak in 1972. And again, a lot of color film uses that developing process today, and I will be going more in depth about that in my next video, where we're actually going to process some color film using the C41 process. So I'll talk about the structure of that film and the chemical process used to develop it. So that is all for today about subtractive color processes, the follow-up to additive color processes, all creating beautiful, cool images, combining science and art together in a wonderful way. I love combining science and art together. Anyhow, thank you all so much for watching. Please continue to join us for this photography series. And today's fun fact we're gonna rate is that Kodak actually got declared a monopoly for its Kodachrome because you could only get it processed by Kodak Labs. So when the US Department of Justice declared they had violated antitrust laws, Kodak was forced to open up their development process to other labs. So that's pretty crazy. Please try to rate that fun fact on a scale of 1 to 10 in the comments below. Like this video, subscribe to my channel, share it with your friends, check me out on Instagram, and keep it science, you guys!